Okay, I've got some more definitions for you. Very exciting content to do. We're going to do some examples with these definitions. So we are going to start by defining some sets. We are going to start with what we call the universal set, which we're going to represent with you. A universal set would be all of the numbers that you're going to deal with for your problem. So basically that set becomes your entire universe. No other numbers exist outside of your universal set. And instead of putting squiggly brackets, we're just going to say numbers 1 through 10 is going to be our universal set. We're going to have set A be odd numbers 1 through 10. And we're going to have set B be prime numbers 1 through 10. So if we wanted, we could list all of those out, which, if occasion calls for it, we will. But for right now, we're not going to worry about it. Okay, the first thing that we're going to talk about is called a subset. And this means to be a subset of something, all elements of one set are part of another. So in our example here, I know that A is going to be a subset of U. And basically that sideways curvy C means subset. I also know that B is going to be a subset of U. Basically all of your sets should be subsets of the universal set. If I decided to throw in another set, maybe the numbers 2 and 5, then I could say that the set 2 and 5 is a subset of set B here, because those are prime numbers. You're going to see something with definitions. You can see a subset symbol be written two ways. You have it this way or this way. And here's the difference here. You could have a proper subset and basically it means it's a distinct subset, like we know that it is an improper subset. Would be that the subset is the same as the set. And so basically what to know with this is that think of it as like a less than or equal to. So like if I said that this set I know is a subset, but it could also be equal to it, maybe we don't know. And so the or equal to line under it, it's not exclusively improper. It just says it could be improper or it could be proper. We're not sure. I don't want you to worry too much about that notation. I would be okay with using either one. You're going to see me mostly use this one, but I wanted you to be aware of the difference. It just means that the two sets could be the same. So technically, every set is an improper subset of itself. Like I said, don't worry about it too much, but now you know what it means. Okay, next up, an intersection. And this is going to be elements contained in both sets. For my visual friends, which includes me, I think it's helpful to have some Venn diagrams here. That intersection would be that overlap part. For a subset, that'd be something like this. This means that A is a subset of B. So for an example, if I wanted A intersect B, well, let's think of what numbers are odd and are prime. A question I get a lot is 1 a prime number? 1, by definition, is not a prime number. A prime number is a number that the only unique factors are 1 and itself. Because 1's only factor is 1, that is not a unique factor. So our prime numbers here, maybe we should just write these down because that'll be helpful. Odd numbers 1, 3, 5, 7, 9. Prime numbers 2, 3, 5, 7. So which numbers are in both A and B? Well, that's going to be 3, 5, and 7. And that is going to be the intersection. So the symbol for that, here, I'm just going to start putting the symbols in red, is basically an upside down U. Up next is a union. And that's bringing everything together. So that would just look like all of this. A lot of times you'll hear that as the word like or, where intersection would be and. So what's an A and B, or what's an A or B? The symbol for this is basically going to be a capital U. So it's A union B. And so I'm just going to list all of the sets and shove them all into one. We do not need to list numbers twice. So if I put them all together in the same pool, we got 1, 2, 3, 5, 7, 9. So that's all of the numbers that are in A or B. Okay, and the next thing we're going to talk about is the complement. So this is going to be all elements not in the set that are in the universal set. So in a Venn diagram, let's call this box the universal set, and then we have set A here. If I want the complement of A, that's just going to be everything outside that. The notation that you're probably going to see most for this is going to be like a little apostrophe. I've also seen it before as like a little exponent of the letter C, but you're probably going to see the apostrophe more. So it's either going to be A complement. You might also hear it be called A prime. Either one, honestly, probably more in life, you're going to hear this as A prime. So we're going to stick with that. So everything that's not in A, that's part of the universal set. Well, that would be our even numbers. 2, 4, 6, 8,